Okay, for the free response part of the Unit 8 test, we're going to take a look at these questions now. Take a look at the pool question first. We've got this rectangular swimming pool. It's 20 feet wide, 25 feet long. Okay, and I'm going to come back and get these dimensions here in a second, but what I want to do is draw a picture of this. So let me go to my smartboard and we'll go ahead and draw a picture of this pool. By the way, a lot of people drew the picture like this. Pools don't look like that. All the water will run out of the bottom. Okay, so what you really want to do is draw it so it looks like a pool. There's the water. Here's the shallow end. Here's the deep end. And there's the other pool. Now you realize that, this goes back like this. It's got width to it also. Okay, so remember that. That's what the pool, that's what this cube of water looks like. Not cube, but this volume of water looks kind of like that. Okay, and so we're kind of looking down on it from an angle. So what we're given, and let me go ahead and flip back to the picture here. We're given positions from the shallow end, and we're also given depths. So I'm going to draw, let's see, we need 1, 2, 3, 4, 5, 6. So let's go ahead and draw 1, 2, 3, 4, 5, let's see, 1, 2, 3, 4, 5, 6. There we go. Okay, now we'll put the dimensions in here. 6, 8.2, 9.1. So 6, 8.2, 9.1, 9.9, 10 and a half, and 11. 9.9, 10 and a half, and 11. Okay? And each one of these intervals then is how far apart? 5 feet apart. So each one of these interval widths is 5 feet apart. Okay, now you can use the left-hand rule or the right-hand rule. They both end up giving you slightly different answers, but the method of doing it is basically the same. We're going to look at, and let me do the left-hand rule, just for grins. We're going to be looking at the area of each of these sub-intervals by approximating using the left-hand endpoint. Let me change the color of that so you can see it better. We're going to use the left-hand endpoint like this. And what we'll do is we're going to find the area of the rectangles, okay? And then we got to multiply it by 20 because we need the volume of the water, and the volume of this rectangular slice is the width times the height times the depth. Okay, so if we're using the left-hand rule, the volume of this first section is going to be the height of it, which is 6 times the width times 20. The next one, 8.2 times 5 times 20. The next one, 9.1 times 5 times 20. The next one, 9.9 times 5 times 20. And the next one, 10.5 times 5 times 20. Okay, now here's what a lot of people did. You did all 6 of them. This one doesn't get counted in the left-hand rule. It can't because we're using the left side, not the right side. So I'm going to go ahead and pause this for a second. Let me compute all of this up, and I'll tell you what the answer is with the left-hand rule. The left-hand rule ends up being 4,370. And what units are we talking about? Okay, a lot of people miss the units. We've got the position in feet. We've got the depth in feet. So the interval width's in feet, the depth is in feet, and the width of the pool is in feet. So the units here are going to be cubic feet. The right-hand rule works very similar. The only difference actually is that this first term is not used in the left-hand rule or in the right-hand rule because it's the left-hand endpoint of the first subinterval. So what we're going to do with the right-hand rule is we're going to start with the second term up here. We're going to start with that one. Okay, and then we'll go 9.1 times 5 times 20. Okay, and then the last term is going to be this one right here, the 11. 11 times 5 times 20. And if you figure all that out, you get 4870. The only difference between these two is that in the right-hand rule, we use the right hand or the last height. In the left-hand rule, we use the leftmost height. Okay? Cool. There's problem 1. Now let's go back and take a look at problem 2. All right, a driver averaged 30 miles an hour on a 150-mile trip and then returned over the same 150 miles at a rate of 50 miles an hour. He figured his average speed is 40. Okay, we'll do part B first. The error of his ways is that he spent longer traveling 30 miles an hour than he did traveling 50 miles an hour. The trip there took longer than the trip back. And so what happens is the speed doesn't get weighted, or it's not supposed to get weighted equally, because he spends more time doing this trip than that trip. So what we really need to do, find his average speed, is how far did he travel? He went 150 miles this way, then he went 150 miles that way. So he went 300 miles. How long did it take him? Well, it took him 5 hours to do the first trip there, because 150 miles at 30 miles an hour is 5 hours. It took him 3 hours to come back. So it took him 8 hours total. And if you divide that out, you get 37.5 miles per hour. There's problem 2. Okay, problem 3. So we're given the following definite integrals, and we want to find the integral from -1 to +4. Okay, if you notice, these sets of integrals, here's the one for f, here's the one for h. The first one for both of them goes from -1 to 1. The second one goes from 1 to 4, but this one goes from 4 to 1. What we'd really like to do is be able to go from -1 all the way to 4. We can do it with this one very easily. Because of these two integrals, the integral from -1 to 4 of f of x is just the sum of those two, right? Because we go -1 to 1, 1 to 4. So the sum of these is 5 minus 2 is 3. This one's a little tougher. We go from -1 to 1, but we really want this to start at 1 and go to 4, not the other way around. So what we do is switch this. And remember, when you switch the limits of integration, you switch the sign of the outcome. And now we can just add these two up. -1 to 1 and 1 to 4 makes a nice single definite integral. And we add these two up, we get 13. When you add them up, and 13 plus 3 is 16. And there's your answer. There you have it, the free response questions for Unit 8.